Hi everyone, welcome back to my number sense series. In this video, we're going to keep talking about base conversion, but this is going to be a very special case. In this video, we're going to learn how to convert from base 2 to base 4 and base 4 to base 2 without using base 10 as an intermediary at all. So what I mean by that is often in number sense, they're going to give you questions where they give you, 1011101 in base 2, and they want you to translate that to base 4. And the naive approach is to use what we already know, turn that into base 10, and then turn that base 10 number into base 4. And while that certainly works, there is a much better way that I'm going to show you right now. But in order to understand the motivation for the better method, let's first see what the answer is with the more naive method. But don't worry, it won't take too long. So recall that base 2, each place has a place value of 2 to the power of something. So this would have a place value of 2 to the power of 0, which is 1. This has place value 2, 4, 8, 16, 32, and 64. So if we want to convert this into base 10, what we do is basically add up all the place values. So we would add up this 64. There's a 0 for 32, so we don't add that. But there's a 1 for 16, 8, and 4. So we add all of those. And there's also a 1 for 1. So we also add 1 at the end. And this would translate to 93 in base 10. Then we know how to translate base 10 into base 4 also, so we could translate this into base 4. Now how we would do that is, first think about how many digits we need. So this biggest power of 4 that is less than 93, you go 1, 4, 16, 64, and then you stop there because the next one is 256, which is way too big. So we have these place values. Now how many 64s go into a 93? Just 1. And after that, we have a leftover value of 29. How many 16s go into a 29? Just 1. And we have 13. Then how many 4s go into a 13? 3. And then we have 1 left over. So what we think is that it translates to 1131 in base 4. And this is true. But this is not a good way to do this problem. As you can see, it took me way too long to do this. And of course, if you do it a lot, you're going to get better at it, but not nearly as good as to surpass the method I'm about to teach you. So what is the secret method? Well, this secret method relies on one thing, but I'll tell you after I show you. So here's how our method goes. Take this group into groups of 2, okay? Starting from the right, so you take this group of 2, this group of 2, this group of 2, and then there's only 1 left over, so this is its own group, but you can imagine a 0, 1 over here, same thing. So take this in base 2 and then convert that to base 4. What's 0, 1 in base 2? Well, that's just 1. So we write 1. What's 1, 1 in base 2 translated to base 4? That's 3. What's 0, 1 in base 2 translated to base 4? That's 1. And what's 0, 1 in base 2 translated to base 4 again? It's 1. And so our answer is 1131. Very easy. But we have to understand why this works, because in number sense, they're going to try to trick you. And sometimes, if you just memorize this 2 and 4 case, when you see another similar case like 3 and 9, you're going to go completely belly up. But not if you understand why it works. So here's why it works. First of all, I want to decompose this into its most basic parts, that is the powers of 2 added together. So 0 and 1, let's imagine this 0. Let's imagine we have a 0, and this would have place value 128. So our number in total would be 0 times 2 to the power of 7 plus 1 times 2 to the power of 6 plus 0 times 2 to the power of 5 plus 1 times 2 to the power of 4 plus 1 times 2 to the power of 3 plus 1 times 2 squared plus 1 times 2 to the 1 plus 0 times 2 to the 1 plus 1 times 2 to the power of 0. Now, let's group it into, groups of 2, like I said. So we'll take this group, we'll take this as a group, we'll take this group, and we'll take this group. So now, let's think about it. 0 times 2 to the power of 7 plus 1 times 2 to the power of 6. The important thing that we do here is factor out 2 to the power of 6. Now, when we factor out 2 to the power of 6, what it creates is 0 times 2, because 2 to the power of 7 divided by 2 to the power of 6 is just 2, plus 1. Now similarly, we take this group and we factor out 2 to the power 4. And what that gives us is 0 times 2 plus 1. Now we take this group, a 1 times 2 cubed and 1 plus 1 times 2 squared, and factor out a 2 squared. And what that gives us is 1 times 2 plus 1. Then we take this and factor out 2 to the power 0, which is of course 1, so it's the same thing. 0 times 2 plus 1. So now we have this expression, and maybe it doesn't look better, but it actually is, and let me show you why. So 2 to the 6th, 2 to the 4th, 2 squared, and 2 to the power 0. All those exponents are powers of 2. Sorry, are multiples of 2. And why are they all multiples of 2? It's because we group them in a way such that they would all be, this is a group of 2, so we can factor out multiples of 2. Here we have 2 to the 0, 2 squared, 2 fourth, 2 sixth, 2 1, 2 cubed, 2 fifth, 2 seventh. That makes it so that when we factor out 2 to the power 6, 2 to the power 4, 2 squared, 2 to the 0, they all line up nicely. So then, instead of thinking of it as 2 to the power 6, think of it as 2 squared cubed. In other words, think of it as 4 cubed. Think of this as 4 squared, 4 to the 1, 4 to the 0. And then it becomes very clear. 4 cubed times 1 plus 4 squared times 1 plus 4 times 3 plus 4 to the 0 times 1. And here we can see the digits of our answer because this is literally base 4. This is telling you 4 to the power 0, the value of the 4 to the power 0 digit is 1, right? 1 is the last digit. The 4 to the 1 digit, that has a value of 3. 3 is the second to last digit. And similarly, we have 1, 1, 3, and then 1. This is where we get the ability to just take these groups of 2 and then convert them automatically. So hopefully that kind of made sense, but if it didn't, I'll show you another example in this next one. So here we have 0, 1, 1, 1, 1, 1, 0, 0, and 1. So once again, we're going to have to execute something similar. Now this 0, 1, 0, 1 in base 2, let's convert that to base 4, right? What would that be? That's 1 plus 0 is just 1. 1, 1 in base 2, convert that to base 4, that would be 3. Another 1, 1 in base 2, that would be 3. Now this time we have 0, 0, 0, 0 in any base, that's 0 plus 0 is just 0. Then we have just 1, which is just going to be 1. Of course, the same in any base. So again, our answer is going to be 1, 0, 3, 3, 1. And remember that when we group our digits, we always have to start grouping from the right side. Because if we don't start grouping from the right side, we're going to have, instead of like 2 to the 6th, 2 to the 4th, we might end up with something like 2 to the power 7 and 2 to the power 5, and those cannot be expressed nicely as 4 to the power of something. And so it would not work with our base 4. But if we start doing it from the right, it's always going to work because we're going to end up with nice multiples of 2. So we can go this way from base 2 to base 4, but of course we can also go in the other way from base 4 to base 2. Now you might have already figured out how we're going to do it. This is how we're going to do it. If we have a 1 in the last digits in a base 4 number, then to make it base 2, all you have to do is convert 1 to base 2. But don't write just 1, because in base 2, if we wanted to make it base 4, we'd have to use 2 digits. So similarly, if we convert this 1 from base 4 into base 2, we should write 0, 1. Then if we want to convert this 2 into base 2, it would be 1, 0. So that's already 2 digits, that checks out. So then we have a 3, what's that in base 2? That's 1, 1. And notice again the very nice thing. The biggest digit we can have in base 4 is 3. And so 3, when you convert to base 2, that's exactly 2 digits. That's the biggest 2-digit number in base 2. Again, that is a consequence of 4 being equal to 2 squared. So that is the most important thing that makes all of this work. 4 equals 2 squared. Now, something similar, let's try going in reverse again. 3 in base 4, convert that to base 2, you would get 1, 1. And again, once again, we're going to start writing from the right side. Now 2 in base 4, convert that into base 2 is 1, 0. 1, that's going to be 1, but don't write 1, write 0, 1, because we have 2 digits, because 4 is 2 to the power of 2. We have 3, convert that to base 2, 1, 1. 1, 1, 0, 1, 1, 0, 1, 1. This is a lot easier than if you were going to try to convert this into base 10 and then back to base 2, right? Now our last question. It does not appear to use base 2 or base 4. but it is the exact same idea. And this is why I always say to try to understand the meaning, like why things work, right? Here in this problem, there's not something that is intrinsically super special about 2 and 4. The thing that makes this work is that 4 is equal to 2 squared, but there's other squares, right? 16 is equal to 4 squared, 25 is equal to 5 squared, and 9 is equal to 3 squared. So there's no reason why we shouldn't be able to repeat the same thing with base 3 and base 9. And in fact, if you write out the proof, it actually works the exact same way. Literally just substitute 2 and 4 in the proof for 3 and 9, and you should see how it works. So how is it going to work? Well, same thing as normal. Let's make groups of 2. Now 0, 1 in base 3, what is that in base 9? It's just going to be 1. Again, 0, 1 in any base system is just 1. So I'm going to write 1. And once again, remember that these 2 digits become 1 digit. Now 1, 2, what is that? That's 3. So 1 times 3 plus 2 times 1, that's going to be 5. And then just 2, what is that? That's just 2. So 2, 1, 2, 0, 1 in base 3 equals 2, 5, 1 base 9. Really easy, right? And we didn't even have to invent a new trick, because the thing that's special about this video isn't actually 2 and 4, it's a and a squared, x and x squared. Anything and its square, you can use this strategy to convert between their bases. But once again, there's nothing that special about being a square. In fact, we can do the same thing with cubes, just with one tiny adjustment. And we will cover that in the next video. So, despite me saying that this is a video about converting between base 2 and base 4, this is really a video about converting between any base and that base squared. It just depends on you understanding the proof, and then the strategy is really, really the same. So, that's it for today. Thank you guys for watching, and I'll see you next time.